Hi everyone, thanks for joining me in this session. My name is Pam Strong. I'm an Integrated Watershed Management Specialist with the Lake Simcoe Region Conservation Authority. And today I'll be talking to you about parking lot design with winter in mind, how to design safe parking lots that need less salt. So we're very familiar with Canadian winters, snow, ice, rain, sleet, and all the various combinations. I'm sure you've been faced with a lot of these. And the way that we treat them is by putting road salt down. But what happens when the snow disappears? Does the salt? Not always. We always see remnant heaps that are left in the spring, dead grass, and these are some examples that we see. But there are other issues as well. There are a number of threats facing our freshwater resources, including nutrients, particularly phosphorus and nitrogen, which are leading to the overgrowth of plants and algae. Sediment, much of which runs off of roads, construction sites, and agricultural fields, which impacts water quality and aquatic habitat. Inputs of warm water running off of roads and parking lots are affecting aquatic communities, particularly sensitive cold water species like trout. We're still learning more about emerging contaminants and their impacts, and this is an area of continued study. But today, we're here to talk about salt. It's a huge challenge because it's widely used, it isn't regulated, concentrations are increasing, and there's virtually no way to get it out of the water once it's in there. Unfortunately, there really aren't any viable alternatives, so we need to look at how we can reduce its impact. When we talk about road salt and its impacts, we're typically talking about sodium chloride, the same as table salt. Magnesium chloride and calcium chloride are also used, and these also contribute chloride. The vast majority of the salt that's applied ends up in surface and groundwater. This can take a period of days for surface water or decades for some groundwater aquifers. There are also a number of health and environmental impacts, as well as damage to built infrastructure, including to our roads, bridges, and other built assets. It's important to note that there are no best practices available to us to remove salt from the environment, so the only way to reduce the impact of salt is to reduce how much is applied. I'd like to show you what some of the typical chloride concentrations we'd see are. In an unimpacted lake on the Canadian Shield, we would typically see a concentration between 1 and 7 milligrams per liter. A lot of this chloride comes from the rocks that are around the lake. In the ocean, the salt concentration is about 19,000 milligrams per liter. The Canadian Council of Ministers of the Environment have set two guidelines. The first is a long-term or chronic guideline, which wouldn't be lethal but would impact the life cycle of aquatic life, and this is set at 120 milligrams per liter. The second is the short-term or acute guideline, which would be lethal or cause severe harm to an organism. This is set at 640 milligrams per liter. And just to give you an idea of what the concentrations that we might see around the GTA are, this is a blue crab that was found in a creek in Mississauga, Cooksville Creek, and the concentration in that creek and a lot of creeks around our area typically exceed 20,000 milligrams per liter in the winter. So we're looking at orders of magnitude higher than the guideline. I want to take a big step out and look at North America's lakes. In a study done by Hilary Dugan at the University of Wisconsin, they reviewed all long-term water quality monitoring data from North America and found that 2/3 of the lakes that had data had been getting saltier. Lakes that had roads or parking lots in their catchment areas were those that were most at risk. She found that only 1% impervious surface in a catchment was enough to cause impacts. Expanding out across North America, they found that 11,000 lakes had characteristics that would make them vulnerable to winter salt. And just a side note here, they did find that conditions are stable or improving in Scandinavia. We're not quite sure why at this point, but it's worth another look to see what they're doing. In Ontario, we have the Provincial Water Quality Monitoring Network that tracks water quality in rivers. The Ministry of the Environment staff have summarized the data for over 2,000 streams, and as you can see from this graph, they found that chloride concentrations are increasing here as well. We're still below the long-term exposure guideline of 120 milligrams per liter, but concentrations have doubled since the 1970s. However, it's also important to note that this graph does include all stations, including those from both urban and rural streams. You can imagine that this increase would be much steeper if rural streams were excluded from this analysis. And to give an example of how a particular water body can be impacted, this graph shows how concentrations have increased in Lake Simcoe, about an hour's drive north of Toronto. The amount of urban area has been increasing steadily over the past few decades. You can see that the amount of salt applied to these urban areas has been leading to an increased concentration into the lake. We expect that the lake will exceed Environment Canada's chronic guideline of 120 milligrams per liter by the year 2120, if not sooner. This will have significant impacts on the lake's ecosystem. Now I'd like to look specifically at road salt use in the Lake Simcoe watershed. The map on the right shows us the existing urban areas in gray and the planned urban areas in purple. That's a lot of new urban area, and this will all have road salt applied to it, which will increase the amount that's going into the lake. We've taken a look at what goes into the lake, or what's applied in the Lake Simcoe watershed every year, and it's about 100,000 tons of salt, which is about the equivalent to a CN Tower's worth. On a per capita basis, that's about 225 kilograms of salt used to keep people safe on roads and parking lots. So that's about 2.5 times the weight of an average adult. This pie chart shows that chloride is primarily from the salt used on roads and parking lots in winter. We estimate that 17% of the salt is coming from commercial parking lots. Estimates in other watersheds are actually much higher than this, so we know that parking lots can be an important contributor. We're not just interested in salt for the sake of salt, though. It has a lot of impacts on the environment. It can harm drinking water and is particularly risky for people with sodium-reduced diets. It can damage trees, buildings, and at extreme concentrations can be toxic to fish and impact aquatic food webs. And perhaps most concerningly, high salt concentrations can mobilize other contaminants, including heavy metals, and can reduce the effectiveness of the tools that we use to manage urban runoff. For example, our research over the past couple of years is showing that salt-laden water is reducing the effectiveness of stormwater management ponds to improve water quality. There has been a lot of effort around improving salt use, though. It started with Environment Canada releasing a voluntary code of practice for roads managers in 2004. There's been really wide uptake of this. There is still room for improvement on roads, but Environment Canada and others continue to work on it. Annual reviews are conducted looking at the adoption of the practices, which have found that the code has been broadly adopted and that some of the major best practices around storage and application have been taken up. Areas where some are lagging are in the identification of salt vulnerable areas and in the periodic review and updates of municipal salt management plans. Environment Canada is still working on both of these items. There's also ongoing private sector training and certification, for example, the Smart About Salt program. This was developed a number of years ago. It's a voluntary training and certification program for contractors and property managers. They provide training on best practices in winter salt use, including the science of salt, the importance of using calibrated equipment, and proper salt storage. They also emphasize proper record keeping, which can be critical in fighting slip and fall claims. The training is primarily aimed at parking lots and sidewalks, but is also taken by a lot of municipal staff to improve their understanding of best winter maintenance practices. Until recently, a lot of the focus has been on roads and highways, and there hasn't been a lot of focus on parking lots. As you'll recall, they can contribute a significant amount of salt. The thinking around salt application in parking lots is a bit different, though. Of course, the focus is always on public safety, but the avoidance of liability is a huge consideration for winter maintenance contractors. Contractors in Ontario have been seeing their insurance rates increase by as much as 350% in the last couple of years. Given these concerns, it's become commonplace to apply too much salt rather than risking applying not enough and having a claim made against you. So what are the main concerns around winter maintenance and parking lots? As I mentioned, contractors are really feeling the pressure to avoid slip and fall claims. Parking lot managers can also contribute to this when they ask to see a lot of salt, even when the snow and ice have melted, to prove that they've done their due diligence. They are right to be concerned. As I mentioned, premiums and deductibles are increasing, and some insurers won't even cover winter maintenance contractors. And as I'm sure many of you are aware, the damage to building assets, such as railings, door frames, flooring, cart corrals, and landscaping materials due to salt, can be extremely costly. We're working on quantifying the impact on building assets and infrastructure, but our understanding is that it can be significant. I'm sure some of you have a good idea, as you have to replace these items on a regular basis. If we can reduce the amount of salt that's being applied, the damage that it causes will be slowed as well, prolonging the lifespan of these built assets. We recognize that this is an issue, but what are the solutions? It's important to recognize that reducing salt use will take a multi-pronged approach. There are some guidelines out there, but none of them have been universally adopted, and their use is patchwork at best. So we really need to look at the adoption of a single set of guidelines. Training and certification of contractors would be a logical choice. This would be similar to what was done in Ontario with the pesticide regulations a few years ago. More property owners and managers are actually asking for trained and certified contractors, but there is also an increased cost for contractors to take the training and provide it for their staff, and the contracts are generally more expensive because it takes a bit more planning and work to implement those best practices. It will also take resources to audit the program and ensure that trained contractors are using the practices properly. Regarding liability protection, there are several different models. In Ontario, we're encouraging the adoption of something similar to the New Hampshire model, where the burden of proof shifts from the contractor having to prove that they use best practices to a complainant needing to prove that the contractor was negligent. This protection is for contractors who have been trained and certified using an approved training program. Public education is an extremely important factor with this issue. We need to remind people that we live in a cold, snowy climate and that bare pavement shouldn't be the expectation. People need to dress properly and take appropriate care. As I'll show later on in the presentation, an oversalted surface can actually be more slippery than a properly treated one, so we need to manage public expectations around what salt application should look like. We're looking at a number of these solutions in Ontario with a group of businesses, environmental groups, trade groups, and government agencies to encourage the provincial government to adopt best practices, liability protection, and mandatory training for contractors. We'll discuss improved parking lot design later, obviously, but I just wanted to go through some parking lot work first. So our staff have been studying parking lot salt application for the past 5 winters. Some of the questions that we've been looking to answer are, how salt application rates and timing affect surface friction, how much salt is needed to achieve safer surfaces, and also whether it is possible to use too much salt. So we've been working with contractors around our watershed to see what they apply and when and how they apply it. Over the next few slides, I'll show you some examples of why oversalting might be occurring, and then we'll take a look at how following the parking lot design guidelines could help to prevent some of this. To give you an example of what we would like to see, the picture on the right shows a sidewalk treated with about 60 grams per meter squared of salt. This is around the industry standard for a moderate application rate of 58 grams per meter squared, or 1,376 pounds per 1,000 square feet, for those of you who use those terms. As I'm sure most of you have seen in some areas, this is rarely what's applied. We often see something more like this. So we just saw the ideal at 58 grams per meter. At the other end of the spectrum, this is a pretty dramatic example of an over-application. We see a lot of this, even on sidewalks that are hardly used. It's likely that the only person using this sidewalk would be the person getting out of that truck. Areas like this can make up a huge proportion of the salt that's applied, and it really isn't necessary. We see everything between the ideal amount and extremes like this, and we're hoping that we can educate people that this isn't how it should be. To get a more thorough understanding of what the ideal is when it comes to salt application and what it means for safety, we purchased a friction tester to see what a difference applying salt at various rates would make to the friction of a parking lot. It's not too important to know what the mu values are in the left-hand column of the table, but basically what you need to know is that anything close to 1 is ideal. It's like dry new asphalt, and slipping shouldn't be an issue. Numbers closer to 0 mean it's more slippery. These values can be informative, but then it's also important to note that a surface like a dry marble floor will also have a relatively low mu value, but won't necessarily be slippery. So it is informative, but we need to take everything with a grain of salt. I'll start by showing you the same surface in 2 different conditions to illustrate what we are looking at with the mu values. The picture on the left shows dry, clear concrete and has a mu value of 9. On the right, you see the same walkway with a couple of centimeters of snow. This surface has a low mu value of 0.11 and would have much less friction. These 2 photos are a great example of what it means to use salt correctly. The picture on the left shows a walkway where the salt has melted the snow and ice, and there's very little left over, and it has a relatively high mu of 0.63, so it would be considered pretty safe to walk on. This is exactly what we're talking about when we discuss the right amount of salt. It's enough to melt the snow and ice, but there's very little of it left over to dissolve and end up in our water bodies. On the other hand, the picture on the right shows that the mu is quite a bit lower when there's residual salt. These pictures demonstrate that over-application doesn't necessarily result in safer conditions. You're wasting money on materials and effort in applying it, and it's not gaining anything in terms of meeting your level of service. The picture isn't totally clear though. The photo on the left shows an oversalted walkway with a friction value of 0.22. The application rate is almost a kilogram per meter squared. And then the same walkway has the snow shoveled off it on the right, but no salt applied, and it has a very similar value at 0.21. To increase the friction and make this surface safer, the contractor would need to apply some salt according to the weather and traffic conditions. So the friction testing has provided some information, but it's not as cut and dry as we were hoping. We're going to continue to work on this and are hoping to get some more real-time measurements with our contractors and refine the messaging around the proper use of salt. Finally, I included this table to show you what the friction values mean in terms of real-world applications of this type of information. So I'll get my pen here. The column in the middle here shows you the mu value, and the column on the right shows you the stopping distance. And we have this for two circumstances. We have it for parking lot speeds and for street speeds at 50 kilometers an hour. So what I wanted to point out is that in an oversalted area in a parking lot, the stopping distance of 7.2 here is only 2 meters less than that of a snow-covered area, but it's actually 5 meters more than an appropriately salted surface, and almost 6 meters more than a surface with bare pavement. And looking at street speeds at 50 kilometers an hour, you can see here that the oversalted surface at 44.7 is about 20 meters less than that of a snow-covered surface, but it's 30 meters more than that of an appropriately salted surface. So this demonstrates the importance of applying the right amount. And again, we're going to keep working on refining this message. Turn that off. So now we'll look at the parking lot design guidelines for salt reduction. The previous slides have shown us the importance of applying the right amount of salt to maintain safety. These guidelines were developed to make that easier. In a nutshell, the goal of the guidelines is to promote the construction of sites that don't require as much salt application for winter maintenance. In other words, to design parking lots that inherently need less salt applied to maintain the same level of service without increasing the exposure of contractors and parking lot managers to liability. These guidelines were developed in 2017 with a group that included planners, engineers, contractors, building managers, and building owners. And we've been working since then to inform people about them and have them adopted and implemented by the appropriate agencies, and also adopted by parking lot designers and consultants. So I'd like to start out by showing you some examples of the good, the bad, and the ugly in parking lot design. The guidelines were developed because this isn't something that's typically given a lot of thought when parking lots are designed, and the results often speak for themselves. We're looking to have more examples like these, and sorry, I'll get my pen again, where you have designated snow piles or covered walkways, and less of this, where you've got pooling areas that'll require more salt, way too much salt here. I'm guessing this is icy. These piles left over at the end of the winter, and then these landscaping features that look really nice, but they're going to get in the way of your snowplow equipment. There are 4 components to the guideline package. I've got my pen on still, sorry. The first section of the guidelines is comprised of a fact sheet and detailed design drawings for 4 features that the group selected. These features were grading and stormwater collection, snow pile placement and design, and the impetus behind these 2 was just making sure that meltwater doesn't cause issues with refreezing, and you'll see that more later. Next, we looked at pedestrian flow and walkways, which is about reducing the amount of unnecessary walkways, streamlining the flow of pedestrian traffic. Next, we look at landscaping, so how you can use your landscaping as a drainage feature, and also what types of vegetation you should use. Next, we developed site plan scenarios for a number of development types to demonstrate how each of the 4 features in Section 1 could be incorporated into a site. So these site plan scenarios included 3 sizes of commercial development, so we had a large, medium, and small, and also a small institutional development. And the example that we used was for a school. Once the guidelines were completed, the next step was to determine how to have them widely adopted and implemented. Municipal policies requiring the consideration of these features was a logical place to start. If we start requiring designers to consider these features, the practice will eventually become normalized. The town of Innisfil, north of Toronto, has already gotten started on this with their own policies and has seen some success. And then finally, we also created a fact sheet to communicate the information in a simple, brief manner for those who are interested. Now I'll go through each of the 4 feature types that are highlighted in the guidelines and demonstrate how they help to reduce salt. The fact sheet for each feature includes a general description or overview, design recommendations and salt reduction recommendations, design aspects that should be avoided, operation and maintenance considerations, as well as costing information. So there's a fact sheet like this for each of the 4 features that we discussed, but I just wanted to show you this one as an example. So first I'll look at effective grading and stormwater collection. General thoughts around this, we're looking for a target grade of 2 to 4% throughout the parking lot to ensure drainage. You want to have a maximum distance of meltwater flow. So again, you don't want that meltwater flowing too far. As you see in the photo on the left here, it's flowing from that snow pile and you don't see any stormwater infrastructure anywhere in the picture. And also you're looking to reduce flow over drive aisles and walkways. So looking at this picture here, you have the downspout draining right onto a sidewalk. On a cold day that would turn to ice and would require a lot of salt. So you want to avoid things like that. So we'll look at that in a little bit more detail in the next slide. So here's the design drawing for grading and stormwater collection. The aim is to have a grade of 2 to 4% throughout the parking lot to reduce ponding and refreezing. The surface should be graded away from buildings in such a way that meltwater does not cross pedestrian pathways and other heavily used areas in the parking lot. You also want to have relatively small sections, like the blue section in the middle there, of the parking lot graded to drain to catch basins. This will minimize the distance that meltwater has to travel and also reduce the chance of refreezing. Ideally, you'd have the catch basins located in the middle of the drive path to allow for traffic to help break up the snow and ice. You can look at curb cuts along your LID or bioretention features to allow meltwater to drain into your landscaping features. And again, noting the roof leaders, you want to make sure they're draining away from buildings and sidewalks and into catch basins or into landscaping features. In a nutshell, proper geotechnical design and quality control during construction are extremely important to ensure that settling doesn't occur, because you don't want to see that pooling in the parking lot once everything's said and done. And if you design in this way, the salt application can actually be concentrated in the upgradient areas of the parking lots, and then you can rely on meltwater runoff to convey salt to the downgradient areas, instead of having to apply a high level of salt to the entire area. Next, we'll look at snowpile storage location and design. So there are a few considerations that we want to look at here. You want to have designated and signed areas, like we're seeing in the photo on the left here, where you've got a sign and your snow pile. You also want to consider the location, so looking at things like grade, wind direction, traffic, and sunlight, and also ensuring that you have a short distance to stormwater infrastructure. So again, in this photo, sorry, my face is kind of hiding the snow pile, but yeah, you have your snow pile here and there's no catch basin in sight, so you just want to make sure that that's closed. So we'll look at that a little more closely on the design drawing. So what we're looking at here is they specify that snow piles should be located in low traffic areas, along the outer edges of parking lots, and also down gradient from high traffic areas. So ideally, you'd have your snow piles at the lowest point in the parking lot. This is going to minimize the risk of meltwater draining across high traffic areas and refreezing. Grading is also important because you want to ensure that the runoff from piles flows away from high traffic areas. As I mentioned, catch basins should be located directly down gradient and close to the snow storage piles to minimize the area of the parking lot that's subject to runoff. You could look at doing a treatment train approach, including oil grit separators, vegetated filter strips, and grass swales, to use downstream of snow piles, which will improve the quality of your runoff water. And just thinking about melting the snow pile, you should situate them in areas that get a lot of sun, so canopy free or south facing, which will accelerate melting. And you also need to be cognizant of the prevailing wind direction and make sure that you place your snow piles on the downwind side of the parking lot so that you're reducing drifting. As you can see in the diagram here, they've designated actually multiple snow storage areas. So you have the main one on the right side, but then there's 2 smaller spillover storage areas. And those may be needed to make them easily accessible for plows or for other machinery. And I didn't mention in the last slide, sorry, but you do want to make sure that your snow plows have a clear drive to the snow piles. So that's another important consideration. You should also clearly mark your storage areas with signage. This is to inform winter maintenance contractors where to pile snow and ensures that if different staff from the maintenance company are doing the lot, that they'll know where to put it. And it also prevents people from parking there. You can look at things like mountable curbs or curb cuts, which would allow the contractor to push the snow over the curb into the designated snow storage areas. And then it's also important to prevent visual obstructions for parking lot users. So next we'll look at sidewalk design and pedestrian flow. The overarching thoughts here are just looking at the efficient, intuitive use of sidewalks, considering covered or heated sidewalks near buildings, and also considering the width. So it'd be nice to accommodate snow machinery where possible. So again, in general, what we're looking at is just trying to avoid sidewalks like the one by the truck here. That's completely unnecessary. They're all going to be salted, and it's going to be lots of it. And then looking at things like this, where you have a straight, clear path from the parking lot to the building, and it's also quite wide, so it probably could accommodate some snow clearing machinery. So looking at the design drawing, the first consideration is that pedestrians will typically follow the path of shortest distance, and they don't necessarily use the designed walkways, which occasionally results in pedestrians walking along the vehicle routes and not the designed walkways, especially in large parking lots that have walkways around the edges. So you'll need to verify that the number of sidewalks for the building is suitable for pedestrian traffic. Any extra, again, are likely to go unused, but they're still going to be heavily salted. You should consider the pedestrian traffic to and from buildings to transportation corridors. So you can see here, I'll just grab my pen again, at the bus stop here. So there's a clear path from the bus stop to the building. Looking at the main pedestrian flow, so maybe there's a subdivision over here. And then as well as vehicle traffic. You can look at vegetated islands to help protect pedestrians from traffic. So there's some along the walkways here, this one here, excuse me, but you should be limited and also strategically located so you're not interfering with plowing equipment. Partially covered walkways like overhangs, which would present an issue on walkways due to roof drainage and refreezing, should be eliminated, but they can be replaced with centralized covered walkways and main building entrances where you can. The runoff from any overhangs, again, should be directed to appropriate stormwater management facilities and not onto paved surfaces. You could also consider designing the width to be at least 1.5 meters so that the snow can be removed by conventional equipment and not by someone with a shovel and a bucket just putting down salt willy-nilly, or not shoveling at all, actually, which is what happens in a lot of cases, and just using the salt to melt the snow. Snow storage locations for walkway clearing should be located to prevent meltwater draining over the walkway, similar to with the snow piles in the last few slides. And then walkways should be properly graded to promote drainage as well and minimize refreezing. You could also consider different materials. You could have rough materials to add traction or dark materials to promote solar heating. And then another option is the use of heated walkways in front of the building, which could be considered to limit the amount of salt applied, and it would also limit the amount of salt going into the building. So these would mostly be considered near building entrances. And then finally, we'll look at the landscaping feature. So what you really want, again, is to consider facilitating the movement of snow removal equipment. You want fewer islands and landscaping features, and you would want to keep your landscaping features around the perimeter of the property. And then also plant selection is an important consideration. So looking at where you would plant deciduous versus coniferous trees, as well as looking at salt-tolerant vegetation. So these are a couple of pictures. Again, it's nice that they have these LID features, but again, it would be a nightmare for your snow plowing equipment. This is a bit better on the left side here, where you have these nice vegetated islands instead of sidewalks. But again, you just want to make sure that it's allowing your equipment to get through. And then also making these into LID features would be a good consideration. So just looking at the design drawing here, the layout of the parking lot should be conducive to mechanical snow removal by snowplows. So again, minimizing the number of tight turns and obstacles that the plows would encounter and allowing them to plow in straight lines as much as possible. As we mentioned before, landscaped islands can be kept to the outside or ends of the parking aisles. So you have these here and a little one here. But all of the rest of these can be painted end markers, which would be used to delineate the ends of the aisles, and that makes it a lot easier for the snowplow equipment. You can have curb cuts around the perimeter of the parking lot to promote drainage into your landscaping areas. And the type of vegetation that you use should be carefully considered. You should obviously consider, give preference to salt-tolerant native plants where you can, particularly in the vegetated islands, filter strips, and swales that are going to be receiving a lot of that runoff water. And the guidelines actually include a list of some commonly used salt-tolerant plants. If you include trees in your landscaping plan, you could consider using deciduous trees with high canopies to maximize solar energy, so along your walkways and near your snow piles. So you want the sun in the winter to help melt things, but in the summer you might want shade. So that's another consideration. And then if you're going to use evergreen trees or shrubs, those could actually be used as a treed windbreak along the site perimeter, depending on the predominant wind direction and whether you have enough space to use that as a windbreak. The inlet of a bioswale should be designed to promote sheet flow in order to limit erosion and also to maximize contaminant removal. So you can use your landscaping features to actually improve the water quality. But there is pre-treatment recommended before the water goes into the bioswales. And then finally, looking at the vegetation in your bioswales, if you're using them, should be both flood and drought tolerant, as they'll likely be exposed to both situations. So plants with deep roots. And then you can also use your bioretention features to collect runoff from roofs and canopies, but combined with other upstream salt reduction design features to improve water quality. And then the final consideration is if you do want to include vegetation that's not necessarily salt tolerant, you could use raised planters to protect the vegetation, and then that way you're not replacing your landscaping materials every year. So now we'll look at the site plan scenarios that were developed. So the site plan drawings are where we start to incorporate some of the features that we discussed earlier, and I'm just going to go through a couple of these to show you an example of what we're looking at. So this is the medium commercial site. It's about a 5-hectare site, and I'm sure it's very hard to see, and I apologize for that, but I'll just walk you through some of the features that you'll see on this site. So you have roof leaders that drain into bioretention features, so I think those are along here somewhere. Meltwater is treated in a treatment train before it's discharged to the stormwater infrastructure. There are designated signs, snow storage areas, so you see them around the perimeter of the parking lot here. And then there's also spillover storage, as I mentioned. And there are curb cuts in this drawing, which will facilitate the meltwater movement into the bioswale. The bioswale specifies that it should have native salt-tolerant vegetation. There's a single main pedestrian walkway, which goes through the center of the lot. It leads directly from the far sidewalk over here, which includes a bus stop. So I don't know if you can see that, probably not, to the main entrance of the building. So you can see that it's just very direct and you don't have any extra sidewalks that people aren't going to use throughout the parking lot. The pedestrian walkways are raised to prevent additional snow or meltwater from accumulating. And then there are also heated walkways that are specified near the main entrances of the building. There are a limited number of vegetated islands to ensure clear paths for snow clearing equipment. And then in other areas, they use those painted end markers that I discussed. Excuse me, and the drawings also specify the use of deciduous trees for those features. And again, as you can see here, which we've mentioned in the drainage area, sorry, it's getting pretty marked up here, you can see that there are relatively small areas, graded at 2 to 4%, draining to each catch basin. So I'll just look at the institutional site as well. So as I mentioned, this was the school site. So the drawing specifies that the parking lot is graded away from the building with a grade of 2 to 4% where possible. The parking lot and bus drop-off areas have those relatively small areas draining to a central catch basin, again, minimizing the distance that meltwater is going to travel. It says that the roof leaders are discharging to pervious surfaces, and I can't see where those are, but yeah, something around here. It's discharging over to the grass here. They have elevated walkways, which again will provide drainage and prevent refreezing. And then rather than having curbs or landscaping features, they use painted end markers to ensure a clear path for the snowplows to operate. They have a number of snow storage areas, and these are all located away from high traffic areas, and also drain a short distance to a catch basin. And they have signs showing their location. And as you can see here, there are also designated snow storage areas for sidewalks and playground areas, which is important in a school. They also specify heated walkways at the entrance, as this is an area that everyone uses, and it will also prevent salt from being tracked into the building and causing damage inside. Regarding landscaping, it specifies native salt-tolerant plants and also urges the consideration of deciduous trees, particularly adjacent to snow storage. In addition, the distance from accessible parking to the main entrance is minimized, and other pedestrian linkages are as direct as possible. from bus stops and main parking areas. There's also a green roof canopy over the main entrance to provide some storage and shelter. So we've gone through the first two sections of the guidelines, and now we'll look at the final two. So the final two components are the template policies and the fact sheet. So with the template policies, we recognized that there would be different needs for different planning documents. And we worked with our municipal partners to create template policies that could be used in a number of different planning documents. And you'll see them all listed here. So everything from official plans to engineering design guidelines to site plan agreements. We wanted to make sure that they had policies available to them that they could incorporate and try to use these guidelines. And then finally, as I mentioned, we also created a fact sheet to provide some high-level information on the guidelines themselves, to introduce the policies, and then to direct users to where they could find additional information. So finally, I'd just like to look at some of the benefits of implementing these guidelines and working to reduce the amount of salt that we apply. This chart demonstrates the potential cost savings from material costs alone for one large commercial property that we studied over a 4-year period, if they applied the industry recommended rates of 58 grams per meter squared instead of the 90 grams per meter squared that they were using. With 1,367 fewer tons of salt used, the total cost savings for this one site over the 4-year period would be $136,000, and that's at the conservative price of $100 per ton of salt. Over the past few years, this cost has been significantly higher than this. In addition to the savings for materials and the application of salt, the reduced damage to built assets could also be an important consideration. Obviously, we'll also see some environmental benefit, which is the reason that we got into this in the first place. You'd see the mitigation of impacts to surface and groundwater sources, and again, less salt applied just means less salt in our water. And we would be working to protect aquatic life and vegetation around watercourses and roadways. So the benefits to the public, obviously public safety is a priority with any kind of changes that we're making, whether it's BMP implementation or parking lot design, but we're also trying to reduce the amount of salt while doing this. Implementing these guidelines will help contractors to keep the public safe, while also keeping our rivers, wetlands, lakes, and drinking water resources safe for generations to come. As a final note, I wanted to point out that we have a dedicated salt page on our LSRCA website under the Watershed Health heading. It highlights the issue in general, as well as in our watershed. It describes how salt works and includes links to a number of articles, to our newsletters and technical bulletins, and to any of the work that we've completed, such as the parking lot design guidelines. And I'd also like to invite you to reach out to me if you have any further questions. So on that note, I'd like to thank you again for coming, and I'd be happy to take any questions.